Hey, what's going on? Oh, there's going to be an echo. What's up? What's up? What's up? I see Days. What's going on, Days? Um, yeah, cool. So, once I figure out my window situation, Twitch main. Yeah. Welcome back. We're going to be checking out the... Oh, hold on a second. I got to get my little avatar working here. Tracking. This camera should be like right there, and then run tracker. Ah, there we go. That works. Cool. Sweet. I'm gonna refresh this window. Cool, cool, cool. Shy Puff? Are you real? Are you a bot? Well, if you're not a bot, welcome in. Today we're working on setting up a REPL, read, eval, print loop for doing some ClojureScript development. This is to ClojureScript transpiles or cross compiles to JavaScript. So we write our web app in Clojure, essentially, or ClojureScript, and compile it to JavaScript, and then JavaScript runs on the browser. But what we can do is we can create, we have a React wrapper. And so we can create all of our HTML, we can edit all of our CSS using Clojure. And then compile to JavaScript and have all of that stuff automatically packaged and running on the server and the client. And the nice thing about it is, yeah, we only have to write in one language. We don't have to. I mean, we still have to kind of know HTML and CSS, but I don't actually have to touch an HTML or CSS file, which is pretty sweet. All right, I'm gonna drink some more water. Hit a little vape, and then we'll get going. Okay, so in the previous lesson, we learned how to use Figwheel to reload code whenever a source file changed, enabling a very quick feedback cycle. In this lesson, we will take a first look into a tool called a REPL, which stands for Read, Eval, Print Loop, and is conceptually similar to the JavaScript console that most browsers provide. While live reloading is a great help when we already have a good idea of the code we need to write, the REPL gives us an environment for writing more exploratory code, trying out ideas and algorithms before making them a part of our project. Just like unit tests, REPL development allows us to test a piece of code in isolation, examining its output and making sure that it matches our expectations. However, unlike unit tests, REPL is more interactive and provides even quicker feedback. So I think most folks have used a REPL before. Python has one. I think there's some like actual factual JavaScript REPLs now. PHP has one. There's like the PHP prompt where you can like just write PHP code. There's even I think CERN, which is the Large Hadron Collider, the particle physicists over in Switzerland, and it runs through a few a few countries, Germany maybe, and some others. Yeah, the team over there I think developed a REPL for C++, which is I can't remember the name of it now, but that's pretty interesting. Anyway, so let's review last lesson real quick. I can show what we did in the last lesson. We have this web server that's running, and I can show you that in Emacs here. Oh, that was the other thing, is I committed to doing everything in Emacs. Sorry. Just wanted to give it a try, get a feel for it. Oh, and this is the what do they call this, terminal emulator running in Emacs that shows all the server output. So I think that this little localhost server is still running. So if I come into our file here, we can change something. So like I'll just change this header from a 1 to a 3. So I think I can do this, change character. Oops. Let's undo that. I think that was change line. Undo. Okay, so if I hit that once, and I think I can just change it. No. I'll delete it, go to insert, and then change it to H3. And that should make it smaller. So once I save it, yeah, you can see that it changed to a H3 over here. So the live reloading is really helpful for doing design and whatnot. You can test your changes immediately, which is cool. And that goes for any, like, I can change any of this code in here, and once I save it, we'll get an immediate reload. Useful. I think that's useful. All right. So that was the previous lesson. In this lesson, we're going to look at the read eval print loop. We can grab a REPL. I think there's a REPL that's built into Emacs specifically for ClojureScript. I'm trying to remember the name of it. Cider, I think, is the name. And I'm not sure what. I think they're going to talk about this very basic prompt. So this REPL, I think this is technically the REPL running in a terminal emulator here. Or it's waiting for some input. It's not running in the terminal emulator is connected to the REPL and waiting for input. All the terminal emulator is a just a textual interface to either a shell, or in this case the REPL, which is running on top of a shell. So the interesting thing about if I use the built-in terminal emulator up here for I'm on Manjaro right now. It's a flavor of Linux. I can run like print working directory up here. I could run cljs, clj, and it'll give me a prompt. Okay. We'll just, I think send it there we go. Send it the end of file. Control D is what I pressed there. So that's like interactive, although it is hard to copy things. That's one of the things, like I can select this, but then like Control C doesn't work. And it does have a right click menu. But this here, as you can see, I can move around inside the, I can go to insert mode and like edit things in here. You know, that's not something you can do in the built-in terminal emulator for Linux. So it has other features as well. We can go over them another time. But yeah, so anyways, let's continue. In this lesson, understand what a REPL is and how to use it. Use Figwheel's REPL to experiment with new code. Learn how the REPL interacts with a browser. Understanding the REPL. As we mentioned above, REPL stands for read eval print loop because it reads each expression that we type at the prompt, evaluates that expression in the context of a web browser, puts the result of that expression back at our command line. This process is illustrated in the figure below. Okay. Print. Read. And then eval. Print. Read, print, eval. Right. So let's try this real quick. We'll try exactly what is written there. We're going to go to insert mode and go +7.3. Then we'll hit enter. It should compile to JavaScript, evaluate it, and then give us the output. Let's see. No. Try it one more time. There we go. And this is, it echoes, this particular terminal emulator echoes the input. Great. The read eval print loop. First, the REPL waits for input from the user. Once we have input, a ClojureScript expression, it compiles the expression to JavaScript and sends the JavaScript code to a web browser via a WebSocket to be evaluated. Once the browser evaluates the JavaScript code, it sends the result back to the REPL. Finally, the REPL prints the result and waits for more input from the user. This loop continues until the REPL is killed or the browser that it is connected to is closed. Remember that the ClojureScript REPL is only in charge of the read and print portions, and it needs a browser to perform the eval step. So if you kill the browser, the REPL will not be able to evaluate anything else until you open a browser that it can connect to again. Kind of neat. Note, there are several different REPL options with ClojureScript. We will be using Figwheel throughout this book. Much of the information will apply to any REPL, but be aware that other REPLs may function slightly differently. Notably, it is possible to run a REPL that uses either a node that uses Node.js to evaluate compiled JavaScript. Okay. Simply providing a REPL is not all that interesting. After all, Ruby and Python have REPLs, or interactive interpreters. And every modern browser has a JavaScript REPL built into its development tools. What makes a REPL unique for ClojureScript is that ClojureScript is a compiled language. That means that the REPL reads ClojureScript, compiles it to JavaScript, evaluates the JavaScript code, and prints the results back in the ClojureScript REPL, all completely seamlessly. Other compile to JavaScript languages commonly offer an online interface for pasting in portions of code and viewing the JavaScript that the code would compile to. But ClojureScript is in a league of its own when it comes to giving the developer a dynamic, interactive programming environment. Using the REPL, we can have confidence that the code does exactly what we want it to do in the browser that we are running. Using a REPL for browser interaction. In order to load a ClojureScript REPL, we'll use the same Learn CLJS weather app that we have been using through this unit. All right. So we already have that running. It's already running. I'm tired today. Gee, shaw. In order to load a ClojureScript REPL, we'll use the same Learn CLJS weather app that we have been using throughout this unit. So we're running that already. That's this thing. In most cases, Figwheel will be able to open a browser tab directly. But if it did not do so, please open the browser and visit your localhost server so that our REPL can connect and start evaluating expressions. ClojureScript REPL instantly compiles the code that we type in the JavaScript and evaluates it in the context of a browser. In the previous lesson, we started Figwheel, opened a browser, and navigated to HTTP localhost 9500. We used this setup to reload our code every time we saved it, but Figwheel also started a REPL in the terminal that can communicate with the web page. In order to use REPL, we can simply start typing expressions into the terminal window where Figwheel is running, and it will execute in the context of the page in which our application is running. Additionally, we can interact with our application code and even change it on the fly. Typical ClojureScript development cycle follows these steps. Experiment with entering expressions in the REPL. Does it work as intended? No. Experiment some more. Does it work as intended? Yes. Copy output from REPL into a unit test. Copy functions from REPL into application code. Save application code and watch it reload. Okay. I like this. I like this. This is cool. While we will not use this full workflow in this lesson, we will explore the REPL to see how we might use it for exploratory development. Once Figwheel is running and we have loaded our app in a browser, we should make sure that we can see both Figwheel and the browser. Since we are using the REPL extensively, let's take a moment to make sense of this command line interface. All right. So we have a prompt that starts with the current namespace. In our case, it's cljs.user. We may type a single expression at the prompt. The evaluated value of the expression is printed below the prompt. Once an expression is evaluated, we may continue entering more. Cool. When the REPL starts up, it will display a prompt that has the namespace cljs.user, followed by a fat arrow. That is the equal sign and greater than. As mentioned in passing earlier, the namespace is the fundamental unit of modularity. As mentioned in passing earlier, the namespace is a fundamental unit of modularity. It is used for grouping similar functions and data together. So kind of how we, in object-oriented programming, group. Hi, Johnny D. Photo. This is not Valheim. Oh, am I currently set to Valheim? My bad. My bad. I can fix that. Let's play Valheim, though. Like, when are you available to play Valheim? Software and game development. Done. Done. All right, it's fixed. My bad. Yeah, tell me when you want to play. I mean, I can take a break at any time and switch. It's cool. It doesn't matter to me. Pretty small. This is a pretty small stream, so. What do you think of this so far? REPL driven development. Have you been here for very long? In 5 minutes? All right. I'm gonna read this next paragraph and then I'll switch over. After this prompt, we can start inputting expressions one at a time. Actually, let me reread this workflow. You have a meeting. No, you've been here for 5 minutes. Okay. Your meeting about to start. Okay, sure. Get back to me. I'm going to keep reading then. An expression can span multiple lines, but as soon as we conclude the expression, the REPL will evaluate it and display the result on the next line. There's some expressions that are only run for side effects and have no meaningful value, such as print line. Cool. No problem, Johnny. Thanks for stopping by. I appreciate it. In this case, the REPL will print the string side effects and return nil, indicating that the expression itself has no value. I'm going to try that. Typing in print line. Side effects. Hit enter. Did I? Oh, I didn't type it in correctly. My bad. print. Run that. Run it. Do I have to be in insert mode to run it? I do. Side effects, nil. Okay, cool. Interesting. Strings in the REPL. Note that the REPL displays special characters as they were entered complete with \. But if we print the string with print line, the special characters are printed in the intended manner for display. cljs.user. Huh. Interesting. Try that. So we go new slash \n. Oh, I guess we are giving it a string that it will echo. \. Well, that didn't work. Oh, print line, new line. Cool. K for cut? No. Delete, and then paste. That's not where I wanted to paste it. Oh, I want it. There we go. And then DW. Oh, oops. Undo that. Delete that. Okay. And this is we need to call the function. We need to call the function print line. What? Come on. There we go. Enter. Cool. All right. Cool. All right. I forgot to join the streaming channel on the Discord, but I'm there now. So if you have questions or you want to make a comment, feel free to hop in, stop by. Okay, in order to change to a different namespace, we can use the in namespace function. So in-ns function. This function takes as an argument a symbol with the name of the namespace to enter and changes the REPL's environment to that namespace. For example, to change into the main namespace of our application, we can simply enter in-ns space backtick, I think that's a backtick, learn-cljs.weather. To draw an analogy to a file system, a namespace is like a directory. Defining a variable with a def or defn is like creating a new file. Defining a variable with a def or defn is like creating a new file. And in-ns is like using cd to change to into a new directory. Once in the new namespace, we have access to all the variables defined in it. And any new vars that we define will be defined in that namespace. Okay, so I'm going to, just for myself and for anyone else watching, going to go and look at the beginning of, I think we want to look at building blocks. Yeah, the syntax. All right. So this is an expression which we've used. We used it up here. Println, new line. We also used the add function here. Core types of data. We have numbers. We have text. Characters. Booleans. Keywords. Okay, keywords start with a colon. A symbol, which is an identifier that is extensively used internally. Okay, so kind of a special identifier. Ordered collection, a list, a vector, a map, a set, the empty set or nil, object. This is a special JavaScript object used for interoperability with JavaScript, and an array, which is a JavaScript array, and that is a special object that is used to work with JavaScript arrays. So we know what booleans are. Keyword is an identifier. Symbol is another type of identifier. A list is an ordered collection supporting efficient traversal. Vector is an ordered collection supporting efficient access by index. Map is an unordered collection associating unique keys to values. So this is kind of like a hash map, I'm guessing. No, it's not, because we are in functional programming. So just a map. Unordered collection associating unique keys to values. That's a map. Set. Unordered collection of unique values. Okay. Nil is the empty value. I like to think of it as the empty set, but it's just the empty value. There's nothing there. And then object and array, which we covered. Okay. And symbol is what I wanted to look up currently. Symbols. Symbols are an interesting data type because they are closely linked to the Lisp family of programming languages from which ClojureScript is derived. Symbols are names that usually evaluate to some other object. And we have seen symbols in almost every example without even thinking about it. Okay, symbol referring to a user-defined variable, symbol referring to a built-in function. Okay, so those are the examples here. Of ClojureScript's data types, symbols are probably the most difficult to comprehend. They have a very meta quality about them. They do not directly correspond to another familiar concept. When ClojureScript code is evaluated, it will try to resolve a symbol to the thing that it names. Sometimes we want to refer to a symbol itself rather than the thing that it names, in which case we place a single quote in front of the symbol to quote it, instructing the ClojureScript reader to not evaluate it. Since they are not used very commonly in application code, we will not revisit symbols to the depth that we will with other data types. So maybe we can do a deep dive on that another time. Important thing here is it's not a backtick. It's a single quote. So we're going to go back to the lesson that we were on, which was the REPL crash course. We're learning how to switch namespaces. Here we go. In order to change to a different namespace, we can use the in-ns function, in-ns. All right. Start a figwheel REPL from the command line. Enter some basic expressions. Remember that things like numbers and strings are expressions. So we did that here. I can do it again real quick. That's what this print new line thing is. But let's use the add function. I'm going to go to insert, and then we'll go +3, 5. Hit enter. Try it one more time. I don't think we were connected. +3, 5. Hit enter. Cool. 3 + 5 is indeed 8. So now we're going to use the in-ns namespace learn, and we're going to our web application namespace. Something went wrong. Use of undefined. Oh, I need to quote it. I think I need to quote it like this. Let's single tick like that. Oops. Oh, do it one more time. Then hit enter. Nil. Oh, CL undeclared variable in NS. So for some reason we don't have that here. That's a little snag. Not sure what's going on. Let's try it up here. I'm going to try it in my normal. In my operating system's thing. Okay, so let's go in, or actually we need to start the REPL, so we're going to go CLJ, hit enter. Let's try in NS. Oh, you know what? I know what I did. I don't need to do this. So I'm going to hit Control D to send the end of file and terminate the REPL. And then down here, let's go in. I need my brackets. In dash NS quote learn dash CLJS dot weather. Cool. All right. Forgot about my parens. My bad. Okay, so now I can return by doing the same thing in parens in dash ns CLJS single quote CLJS dot user. Cool. Running code in the browser. All right, this is the interesting stuff, finally. Notice that when we start Figwheel, it opens a web browser before it can load a REPL. Why did we need a browser to use a REPL? Figwheel itself does not execute the ClojureScript code. Instead, it orchestrates the process of compiling the code to JavaScript, sending it to the web, sending it to the browser for execution using the browser's JavaScript engine, then displaying the results back to the terminal window. Cool, and then we've got a little diagram here that shows exactly what we just described. Code being sent from the REPL to the browser. The Figwheel client in the browser evaluating the code and then sending it back to the Figwheel server to be displayed by the Figwheel server. When we enter an expression in the REPL, Figwheel invokes the ClojureScript compiler to generate a piece of JavaScript code. It then sends this JavaScript code over a WebSocket to the web browser. which the browser evaluates and passes back over the WebSocket to the Figwheel server. If there are any exceptions raised while running the compiled JavaScript, the error output is sent back to Figwheel for us to look at. This may seem like unnecessary indirection, but it is actually very useful for a couple of reasons. First, we can have confidence that our code will actually do the right thing in the context of a web browser. And second, we can manipulate the browser directly from the Figwheel REPL. We will now try a few more examples, this time with some DOM manipulation. Okay. So, my colors are off again. There we go. All right, enter apps. So we are going to type in some commands. The first one we're doing is we're going to enter our app's namespace. So in -ns space single quote learn dash cljs dot weather, and I forgot my my things again. Insert. Let's enter. Okay. Forgot my parens. And then I think, was it P to paste? Oh, I have to paste. Why did it paste there? That's weird. No. Undo. Paste. Undo. I'm not sure why it's pasting all the way over here, but okay, I'll just type it again, I guess. Insert, so in -ns learn -cljs dot weather. Enter. Okay, namespace entered. Then we're going to create an input element and add it to the DOM. Parens def input space parens dot create element JS document input. Okay. Object error document dot create element is not a function. Oh, typo. There we go. All right. Now we can go. Did that change anything? No. So number 2, we did. Number 3, def evaluates to the var that was defined. Yes, okay. 4, change the placeholder property of the element. Okay, so we're adding an input, so let's go set, oh, don't forget parens, set parens dot dash placeholder input, go outside the parens, and then we will type enter something. So this is what's going to be the placeholder text for the input, enter something. All right, we will hit enter. Cool, looks like it evaluated that. And now we're going to handle the input. So 5, create an event handler and attach it to the input. Note that this expression spans multiple lines. Okay, I don't know how to do multi-line on this particular terminal emulator, but we will see. We will figure it out. Def n handle inputs e square brackets, e in square brackets. And then I think I'm just not going to go to the next line. I'm just going to keep typing on one line and let it wrap on its own. So we're going to open parens, then type swap exclamation point space app states, app dash states, assoc, ASSOC, space, colon, text, open parens, space open parens, arrow, e dot dash target dot dash value. Okay, I think that's good. And we are going to hit enter. Yeah. Cool. Check out localhost. Has anything changed? No. Let's type in this last set. Parens set dot dash on key up space inputs space handle dash input enter. Okay. After evaluating all these expressions in the REPL, we will have a heading and an input in our app. And whenever we type something in it, the H1 will be updated to whatever we type. Is that true? Do I have those things here? I don't think I do. I'm going to try refreshing. I don't see an input anywhere. So that didn't work. Let's try this again. It didn't seem to work. Let me finish reading this last. We will have a heading and an input in our app, and whenever we type something in it, the H1 will be updated with whatever we type. This is powerful because now we have some code that we know works, and we could simply copy statements from our REPL session and paste them into our application. However, we could even do some refactoring in the REPL before pasting the code into our application. Whenever we redefine something in the REPL, it will affect the running application, so there is no need to refresh the page before we start redefining code. However, if we have added any event listeners or have otherwise modified our DOM, we may want to refresh the page to return to a clean slate. In our case, we will only be refactoring the handle input function so we can continue to continue without reloading the page. So that did not seem to work at all. Def handle input E swap app state assoc text arrow function E dot target dot value. That's fine. Set dot placeholder input, enter something. That looks fine. Def input dot create element JS document input So we define this function here called input, or rather, we define a symbol that evaluates to a function that creates an input. Does a create element. Then we have a function that we call append child body. So did I run this append child? I'm not sure that I did. I didn't run that. Oops. Cool. So this other stuff didn't do anything. This may be messed up. So I'm gonna type this dot. In my haste, I forgot to actually add the call the input function in the right context of the DOM. Okay, let's try running this. Document body, oops, another typo here, append child. Argument 1 is not an object. Okay, so I'm gonna restart this from the beginning. That doesn't work. Can I do Control D here? No. Let me change namespace. NS in NS in dash NS CLJS, I think, dot user. Oh. Right. Dash ns. clj.user? Oh. So I forgot this. Pretty sure. There we go. All right. Let's try to exit. Not defined. Control D. Control C. Oh, nope. Oh. I just figured something out I couldn't figure out yesterday about emacs. Okay. Interesting. All right. Well, anyway, let's go. How do I exit this? Oh, gotta look that up real quick. Exit the CLJS REPL. Quit. Can try quit. Just like that. Nil. We'll try with the no. Quit is undefined. Let's try oh, nice. Okay. And then this should be down. Yep. So now let's run. Oh man, we've typed in a lot of commands. I think it's clj-a fig build. Okay. Type that in so I remember it. Oops. Enter. -a. Oh, I don't remember it. Honestly, my brain is not working right now. That was so weird. Fig. clj-a fig build. Building our application. All right. Then we're going to go back in and redo this one more time. Down here. I'm going to switch namespaces in and S. Learn dash cljs.weather. Go def input dot create element js/document input. Gonna check def input create element js document input. Okay. Done. Now we do the append child. This is what I forgot to do last time. Dot dash body js/document cool. So we created the element this time and appended it to body. Now we can go set dash placeholder of input. Placeholder text will be enter something. Cool. We will hit enter here. Seems to have worked. Def n. We're defining the handle input function. Handle input e swap app state soc text open paren and I forgot to repair this real quick. Forgot my beginning parens. Them here. Yeah, okay. Swap app state assoc text open parens arrow function e dot target dot value gonna double check with the text here. App state soc text target value. Okay, that looks right. That seems to have evaluated properly. Now we do our last set function call here. Dash on key up. Input handle input. Okay. All right, let's check the app. There we go. There it is. So now when I type yo, what's up? So what is the desired outcome here? After evaluating all of these expressions in the REPL, we have a heading and an input in our app. Whenever we type something in it, H1 will be updated with whatever we type. So that part did not work. But we do see that this has been updated. Okay, so which one? On key up input, handle input. So let's look at our definition, function definition for handle input. Swap app state search text e dot target dot value. Yeah, I don't see handle input swap. I don't see us actually calling or referencing H1 at all. So I'm not totally sure how it's supposed to change. Handle input doesn't has a swap function here. Like text is what we're calling? That doesn't seem exactly right. Well, I'm just going to move on. We got the little box to show up. Okay, I'm going to take a little break because I do want to solve this. I want to figure out what's going wrong here. And then I will be back in a couple minutes. All right. Hey, what's going on? I'm back. We're back. We're back. We're back and badder than ever.
I'm back.
Oh, that's probably going to echo.
We're back.
We're back and
Hey,
badder than
what's
ever.
going on?
Oops.
I'm
Oh,
back.
that's probably going to echo. Cool. Unmute myself in the streaming channel. OBS. All right. So we're going to keep reading, and then when I'm done with the chapter, we'll come back to this and make it work properly. I think I know what's going on, but I want to continue moving forward. Okay, so quick review. In your words, explain what happens after you input plus 40 and 2 in the REPL and hit enter. So the closure REPL sends the expression to the browser to be evaluated in JavaScript. Then the return value is sent back to the closure REPL, where closure displays the value in the REPL. Excuse me. Cool. Pardon me. Whew. Should have waited a little bit longer after eating to start streaming again. All right. So, in your words, okay. Look up clojuredocs.org and try running some of the examples in the REPL. Most of ClojureScript's library is identical to Clojure's, so most of the examples will work the same in either language. Sure, I'll take a look at that. Let's go to clojuredocs.org. Okay, cool. No, not quite what I want. Are these the... This is pretty cool. These are companies that use Clojure. I'm going to paste this in the... These are all the companies using Clojure. Ooh, SoundCloud. Cool. Walmart Labs is also using Clojure. Okay. All right. An important note. Anything that we have defined in REPL will only last until we close or refresh the web browser. So if we want to discard everything that we have defined in the REPL, we can simply refresh the browser. Conversely, when in the middle of an involved REPL session, we should take care not to refresh the browser lest we lose the state that we have built up. Fair enough. We will probably want to get the value of some input that triggered an event in multiple places, so we can extract that into its own function. We can also make the intent of the event handler clearer if we extract the updating of the app state into its own function as well. From this short REPL section, we now have some clean refactored code that we could use in our application. Almost all code needs to be refactored, but the REPL-driven style of development enables us to refactor very early in the development process so that by the time we write a unit test or paste code from the REPL into an application, It is already clean and concise. The earlier we are able to clean up our code, the less technical debt we will accumulate, and ultimately the more productive our development becomes. All right, and this is the end of the lesson. In this lesson, we explored how to use the REPL to interact with a web page. We used it both to try out new code and to interact with code in our application's main namespace. As with any skill, practice is key to developing the competence that eventually leads to mastery. And ClojureScript's REPL is one of the best ways to practice new skills. Moving forward, we will introduce almost every topic with a REPL session. We can now start a Figwheel REPL from the command line, understand how code entered the REPL, understand how code entered in the REPL gets evaluated, write and refactor code in the REPL before committing it to our project. Recall from lesson 3 that a symbol must be quoted if we do not want... Okay, that was a little footnote. That's what we looked up back when we were over there. All right, so now that the lesson's done, we're done with the lesson, I'm going to put this to the test. I'm going to refresh the browser and see if the state changes. It does, so we have a fresh state to work from, and then I'm going to try this example again. In -ns. Oh, gotta remember my quotes or my closures in. We're already in the right namespace, so I want to do. Actually, I don't have to retype all of this. I can just check what I wrote. Def input dot create element. This one worked. I know this one worked. Okay. Then we want to append child dot dash body JS document input. That one worked. Okay, so now the input shows up. Then the set okay dot dash placeholder input enter something, so that's the placeholder text, so that should show up down here. Yep, there it is. Okay, so now it is this handle input thing that we cannot get to work properly. So def n handle input e swap app state assoc text paren arrow function e dot target dot value that seems correct, and then the final set dot onKeyUp handle input. Try it. All right, that's all the things. So let's try typing in here. Type something. So it's not swapping it out. And maybe that's because we changed some code in here. I'm guessing we have to change this to back to the hello world. Or maybe Oh yeah, app state. Okay, so let's go and change this here. So we're going to delete word, insert hello dash world is what we're going to render instead here, instead of the greeter. Yeah, I think. And then hit save. So normal mode, right. Okay, and then there we go. Now it's working. Right, okay. So if I hello chat. We got it working. Nice. And so all of that all of that happened live. That is very cool. That is very fast. You're the same guy we talked to about occlusions and stuff. Rye fooled. I don't know. Are you still here? Sorry I missed your message. It's possible. I am the guy. Okay. I don't remember the context of that conversation. There's been so many recently. Good to see you again. We are currently, I just finished up a chapter of this using Clojure to make websites. So ClojureScript, actually. But it's very similar to Clojure. It's a functional language, and it has like just a lot of tooling that's available. You write everything in Clojure. It compiles to JavaScript and HTML and CSS. So you don't ever have to touch a CSS file. I mean, you can, but you don't have to. Or a JavaScript file. You can just write everything in one language. Not only can you write everything in one language, but I can also use a read eval print loop to edit the web page or the web application live. So it's just a really, I don't know, kind of a cool way to get feedback while you're developing. So yeah, once again, we're looking at ClojureScript for web development. ClojureScript compiles to JavaScript, which runs in the browser. And you can write CSS to the browser, and you can write JavaScript to the browser, and you can write HTML to the browser. So like right here, where we define this function greeter, we're actually defining a React component using up here reagent. We're using a wrapper called reagent to use ClojureScript to interact with React. So we can build React components. This is the component I'm currently displaying, defn hello world, I say, and then the text comes from the app state. We used the this thing, the REPL, to add this functionality where we can type and immediately change things. Anyway, let's see what does this say? We were talking about how I thought I was a genius because you can put an occluder node behind the camera, and you explained how occlusion is already native to 3.0 and stuff. Oh, in Godot? Yeah, I kind of remember this conversation. I kind of remember this. Kind of remember this conversation. Can put an occluder node behind the camera. Yeah. That's cool. But this is your first time chatting here. So was I guest hosting on someone else's channel? I don't know. It doesn't really matter. We can talk Godot. That's what I'm going to do next. Yeah, it takes one language and translates it to another. So that's called transpiling or cross-compiling. So, yeah, it will take. I write in this functional language called clojurescript. Can I get a link to the download? What do you want to download to? You want to check out the book that I'm looking at, or do you want to link to the language, the website for ClojureScript? I think this book is a good thing to check out. It'll give you all the links you need. First of all, that way I don't have to type them all in, and it's free. The thing that translates one script to another. That's called a transpiler, and that is going to be different depending on which language you're doing it with. So, like, I think Python has a transpiler that transpiles from Python to JavaScript. There isn't like one transpiler, Uber transpiler. You have to design it to the specific language that you're writing in and the language that you're targeting. Does that make sense? JavaScript to Godot. There is I think there is a language plugin. JavaScript. Actually, I was about to switch to Godot because I just got done with my daily chapter on ClojureScript. JavaScript, Godot, language, plugin. Is it called a plugin? I can't remember right now. The switching terminologies. Binding, JavaScript binding for Godot engine. So this might be an interesting project to you. JavaScript language binding for Godot game engine. This module implements JavaScript TypeScript language support for the Godot game engine. QuickJS is used as the ECMA script engine. All Godot API available. So you might want to try this. I haven't tried this yet. This might be something you want to look into. So like maybe you want to you want to write your Godot scripts in JavaScript. Am I getting that right? Yeah. Okay. Then yeah, the language server or the what do they call it? Language binding for Godot. So JavaScript language binding. This probably works. I'm gonna look a little bit more. It has tons of stars, bunch of forks. It was last updated 6 months ago, so I hope it's not dead. Fixed build for 3.4, so it hasn't been updated for 3.5. Excuse me. So let me see if there's another one. JavaScript support is a third-party module. Modules add built-in support like GDScript, but require compiling it into the engine. With JavaScript, you also get support for languages that transpile to JavaScript, like CoffeeScript and F#. What? That means I can use Clojure in Godot. That's amazing. Okay. So it doesn't look like this has been rebuilt for 3.5, but it's worth it to give it a try, I think. Have you compiled an application from scratch? You don't, yeah, that's what I'm getting at. Yeah. Cuz that's what you're going to have to do to get this to work. Build Godot with ECMA script is failing here. Let's look at this. So let me change my title. No, I don't need to change my title. I'm in the right category. Yeah. All right. So what I'm going to do, let's do this today. This is what I'll do today. Let's go through building this and follow the instructions for building Godot from scratch. You're new but learning JavaScript, and I want to use Godot if possible. So I think if you're like, how new are you? Have you written any code at all? No. Okay. So I can show you how to build the Godot project so that you can add whatever modules you want. You're going through the GDQuest thing. Okay, cool, perfect. Yes, do that. That's going to help you with programming just in general. A lot of, even though you're going through the GDQuest thing in GDScript, the stuff that you learn, the concepts that you learn in there, and even some of the syntax will directly translate over to JavaScript. So that's good. Definitely keep working through that. If you want me to show you today how to, I can walk through the instructions and build Godot from source right now. If you're interested in that, I can show you how to do it. Let me know. You're a teenager and you're homeschooling, and they're teaching a lot of coding basics. Who's teaching? Your parents are teaching you a lot of. If you're homeschooling, are you doing like an online school? Do I rubber duck debug with yourself? Yeah, that's the point of a rubber duck, right? Is like the rubber duck is kind of you. Stiggy man. Thanks for stopping in. Thanks. Welcome in. Welcome in. So you use a thing called Acellus. Acellus. Okay. I'm going to look that up right now. I hope you don't mind. Yeah, I like in real life, I actually have a plushie that I use. But now that I've got this, I just figured out how to get this rubber duck working a couple days ago. So I think I'm gonna I do rubber duck. The other thing is you can jump into this stream, and I will be your rubber duck. You can ask me questions or talk to me about your code, and I will respond. I will be a sounding board for you. You didn't. A Celius Learning Accelerator. Yeah, I'm curious. What is this? Celius for homeschooling. Interesting. Okay. This seems like a company I would enjoy working for. Yeah, cool. So it is an online school thing. Cool. I'm gonna I'll check this out later. I'm gonna add this to my. I like to know what's going on in software education. I love the coding. Stiggy Man says, I love the coding side of Twitch. It's like 200 viewers. Hey guys, I'm making a basic Twitch bot. And then some Joe Schmo is like sitting with 3 viewers. Hey guys, this is day 231 of porting Atlantis to Lost City from PS1 to UE5. Oh, it's so true. That absolutely perfectly describes this category. That's so funny. Oh man. Hey guys, also if you're not followed to this channel and you want to follow, please do. I'm getting really close to affiliate, and I want to play around with making a Twitch bot that uses the channel points. And I can't get the channel points API. Like, we don't get to use channel points until this channel gets to affiliate. So if you subscribe, that would be a big help. Or not subscribe, sorry, follow. You don't have to subscribe. Just give me a follow. I don't need your money. I just need, I think it's like 50 followers or something. Anyway, not a big deal, but... Okay, so let's get out of here. So who wants to see Godot compiled from scratch, from source? Are you all into that? Or should I just play Valheim? Because I'm like done with my... Won't that take a long time? No. I mean, I don't think so. It shouldn't. I mean, let me go back to that web page and clone the source code. Sure. Clone the module. Recompile the Godot engine. The thing is we might compile it and it may not work. Because this says it's failing. But we could try it anyway. Define your eCMA script class and inherit from a Godot class, then export it as the default entity. Save the script with extension JSX. Attach the script file to the node or resource object like you do with GD script. How to export signals. How to export properties. Yeah, so here's the thing, Rye. I think that you should know both GD script. You should know both Godot and JavaScript fairly well before you mess around with this. I think. I mean, you could go ahead and do this, and probably, I'm sure you could figure it out. You seem like a smart person. But I think you'd have an easier time if you practice the two things separately for now. And then once you understand them really well, I would dig into this. But definitely make a note of it and definitely come back to it because it's super interesting. So yeah. Stiggy Man. I mean, my end goal is to get a Raspberry Pi with machine vision to read the side of cars and notify me when the pizza place goes by. Hey guys, this is day 231 of porting Godot engine to the Nokia N-Gage. Stiggy Man, the N-Gage. Nobody knows what you're talking about. That silly phone. All I want to do is add a way to use JavaScript in the Godot engine or translate JavaScript to GD script. Yeah, Rye, this is the way to do it. If that's what you want to do, this site. Did I paste I think I pasted the link up there. GitHub.com geekquilm/ECMA script. All right, this is how you have to do it. If you want to use JavaScript in the Godot engine, you're going to have to read this site and figure out how to compile the engine with this module added to it. I can help you with that. If you have questions, I can help you. In fact, let me give you guys an invite to my Godot server. You can ask questions there. Where is it? It's right here. Invite people. Copy. All right. That's also my Discord. So I make games in there, mostly Godot. There's a lot of nice people in there, artists, musicians, other game designers, 3D artists. It's a great place to ask questions. We're mostly a Godot shop, so yeah, let's look at it. Stupid impressed by people that shit out JS emulators. Like, how the fuck did you get MS-DOS to run on a web browser? What the duck? Oh man, yeah, WebAssembly, Sticky Man. WebAssembly. You can literally port anything to the browser if you can compile it to WebAssembly. All right. Probably. I mean, I don't see how you would do it without Wasm. Like, I'm almost certain. Okay, yeah, I'm gonna look at this project. Copy this. I'm gonna create a new workspace for it. I feel Discord bogging down my system. Why is Discord like this? I don't know. Let's see. Desktop audio, cool. All right. Let's get to it. So we're going to build the Godot engine, or at least look into it. Paste and go. Blazor. I kind of remember. I'm familiar with that name. I'm not 100% sure what it does. Is that a language? You only really know your way around C#. Well, a lot of shops use C#, so not a bad first language at all. Okay, so let's look at this project. JavaScript language binding for Go.game engine. All right, so what we want to do is clone the source code of Godot first. So let's go there. And we're going to go look at this code thing. I'm going to copy this web address. Are you all familiar with the terminal? Go ahead and hit 1 if you're familiar with the terminal, 2 if you're not. You're not, okay. Rye, are you on Windows? You don't know shit about coding, yes. Yeah, the CLI. I might want to be running a Windows so I can show you how to do this in Windows, because I'm on Linux. Yeah. Let me think here for a second. You know, I'm still gonna go through the steps on I'm still gonna go through the steps on Linux. And then tomorrow or another day I will set up a Windows install and I can show you exactly how to do it on Windows. But I get the feeling that you all will probably be able to figure it out. I get the feeling that if I show you this, you'll be able to figure out how to do it on Windows on your own. But another day we'll run through it on Windows. So yeah, I'm gonna create a new project folder here. CD into project. List my projects. All right, I'm gonna make a new folder. Actually, I don't need to do that. I can just clone here. So I'm gonna go git clone. And then I'll paste that address. So I'm cloning. I'm cloning the Godot engine, downloading it from the internet. Given I'm used to Linux, how do you find winget? Decent implementation or just meh? I don't know what that is. What is winget? Is that like a Linux trying to do a Windows clone or something? What is that? apt-get, but for Windows? Never tried it. Sounds cool. I mean, any apt-get is a great package manager, so. Nice. No, it sounds useful. I've never tried it, but I like using Linux because a lot of my work has to do with web servers, and so if I use Linux, all web servers are Linux, almost all of them. And so if I use Linux all the time, then it feels natural to do work on a web server. I'm always in practice. Honestly, to be completely 100% honest with you, I have not touched Windows since Windows 7. Windows 7 was the last Windows I used. But I have heard about Chocolatry. I just never used it. The cartoon theme, yeah. Oh man, so funny. What's that, Rye? What fact you got? Three feet is the size of 3 feet. That statement is in logic is called an identity statement. Kind of, kind of. It's in the form of an identity statement. That's so funny. That is a fact. That is in fact a fact. 3 feet is 3 feet. Yep. Rifled, spitting facts. Stiggy man. Okay, so I'm gonna cd into Godot. Yeah. Okay, so now I have the source code to the Godot engine. Four feet is 2 feet by 2 feet. Yeah, that's true. No, you do have a terminal. You do. You probably don't have Git yet. You have to get Git if you want to be a programmer. Git for Windows. You need this. This is what you use to download source code. Don't get yourself in trouble. Don't download random things that Twitch streamers tell you to download. But this is the Godot engine. I am actually just downloading the code for Godot. Okay, what was the next step? You just want to JS and GD. Why must I go through all this? No, check it out. Watch LS here. -L. There you go. Is that what you wanted? Sticky man? Rifled, why must you go through all this? Well, because you want to change the language that the scripting language of an engine, of a game engine. So that requires a little bit of work. I mean, there, like, let me check and see if there's already a, because sometimes people release custom builds of Go.engine. That might be easier. Go.engine, JavaScript, custom build. Come on, come on, come on, come on. We can. I bet there's a custom Go.builds. I bet there's something. Unofficial Go.engine builds. Here we go. Here we go. Here we go. Here we go. The stability of these builds is not guaranteed. Use them at your own risk. Okay. Do not use these builds to compare performance or binary size with official releases. Sure. Server export templates. Okay, I don't think this is quite what we want. Let's just this guy's. If you can request it to the GD dev team and they can put it in if they want. I mean, you could definitely try. There's no, if there's something Godot is an open source project. If there's something that you want that is not there, others may want it too, and so you should ask for it, because then others may also come in and say, hey, we'd like that as well. If not, what language should I learn for this engine? Okay. There are third-party modules for it, but you'll get a better experience by starting out with GD script. I really think this is the way to go, is just learn both JavaScript and GD script. You can use C# if you're using mono-enabled Godot build. Okay. Yeah, so I don't think there's just